Hey guys, welcome back everybody. Today we are going to talk about how to configure the EIGRP routing protocol on the Cisco packet tracer. So if you see this topology right now, we have a very simple topology, router 1, router 2 and router 3. And they are the two sites. One side we can call as a site number 1 and other side we call as site number 2. You can consider as a this side in the Delhi right now and another site in the Bangalore. And I want to achieve the communication, right? I want to achieve the communication between the Delhi to the Bangalore. So what we can do that if you see the subnet right now that I'm using, it's a 100/24 subnet that has a 100 is IP address of this interface. This IP will become the default gateway for this particular PC, right? Same thing, we have a 101 IP address for this particular PC, 102 IP address for this particular PC, 2.3 for this particular PC, and 2.4 for this particular PC. Then after that, we have a 2.0 subnet in this LAN network, and 2.100 will be the IP address of this particular interface. Again, this IP will become the default gateway for this particular PC right now. And same way, if you see the between the router 1 and router 2, we are running with the 12.0 subnet, 12.1 and 12.2. And between the router 2 and router 3, we are running with the 23.0/24 subnet. So this guys will be the 23.2 and this guy will be 23.3. Okay, let me correct this guy. It should be the 192. Okay, so let's start the configuration. What we can do that first, we'll configure the IP addressing on the router side and the PC side, and then we'll configure the routing protocol. And the last, we are going to do the verification. So let's start with the IPC first of all. On the PC, what we can do that, I need to go in the IP configuration, and I say that 192.101/24. That's my subnet mask information, and my default gateway will be 100. Same way, default gateway must very important if you want to achieve the communication between the two different subnet. And even if the PC wants to go with the internet, right? So you must have a default gateway information. If the PC doesn't have a default gateway information, then they cannot reach to the internet, and even they cannot reach to the different subnet as well. Without default gateway, still you can communicate within the LAN network. Now we have a this PC 102 right now. This guy has a 192 and /24 and the set mask and my default gateway. Same way, this PC 3 we have, it's a 2.3. So let's configure this guy as a 2.3. Come on. 3/24 and 2.100. And this guy will be the 2.4/24 and this will be the 2.100. Now, we don't need to do any kind of configuration on the switch right now because I'm considering all these guys are part of the same VLAN, which is the by default VLAN number 1. And same thing over this side as well. On the router number 1, we'll do the configuration from the scratch, right? Come on. Yep, this is the no and enable config terminal hostname router number 1. So first of all, we need to configure the interface 0/0, which is the LAN interface, right? It should be the 100/24. No shutdown, because by default the layer 3 interface are in the shutdown state. We need to wake up this guy. And same thing on the interface 0/1 as well. I have IP address will be 12.1 as well. Okay. Now what we can do that, we need to jump to the router number 2 now. On the router number 2, also the no and the enable config terminal host name will be router number 2 now. Interface 0/0 IP address will be 12.2/24. This is the interface which is facing towards the router number 1. And same way interface 0/1, which is facing to the R3 as well. So this is the 0/1. This is this interface we are talking about right now, and we are done. If you want to verify quickly, you can see the show IP interface brief. This command is gonna tell you whatever the IP address is configured on that particular interface. The protocol is down because we haven't configured the IP address on this particular interface, and even the it's still the interface are it's a down state. That's why the protocol is down. So let's go to the R3, and on R3 we can do that no and say the enable host name will be R3 and interface 0/0 will be IP address will be 23.3/24. This is the interface again, it's facing towards the R2. Now you can see that both the interface are green, right? Now what we can do, the interface 0/1 IP address will be 2.100 now /24, no shutdown. That's good. Now you can verify it as well. So if you put the command show IP interface brief, it will throw the error because you cannot do the any kind of verification in the global configuration mode. So if you want to perform the verification in the global configuration mode, you need to use the do keyword, do show IP interface brief. Okay, these things we are discussing according to the iOS perspective, right? So Cisco has a multiple types of operating system, right? So right now we are doing the configuration on the iOS, and on this is the behavior on the iOS router, right? So if you have a Nexus operating system, in the Nexus operating system, you don't need to use the do keyword. Next, what we can do that I have done with the IP address configuration. Now we need to go and configure the routing protocol. So I start with the router number one. On the router number one, what we can do that I'll say the router EIGRP, right? If you put the question mark, you have a bunch of routing protocol option, and I have enabled the EIGRP right now, which is the enhanced version of the IGRP protocol. And then after that, I need to define the autonomous system number. It's a 16-bit of number, and that's all. If you want to configure the router ID, you can configure the router ID as well. EIGRP router ID 1.1.1.1. Make sure that router ID is just a name of the router, right? I don't have any IP address of the 1.1.1 on the router number one, but I still configure the router ID 1.1.1.1. All good. I'll make a separate video on the router ID. And now what we can do that I'll advertise my network. My network will be 2.0 and my network will be 1.0 as well. That's all. Same thing on the router number two now. On the router number two, I'll go in the config mode. I say the router EIGRP. Make sure that AS number has to be same. So the AS number that I'm using on the all the router is EIGRP number one. And I say the EIGRP router ID will be 2.2.2.2. And network I have a 12.0 and network I have a 23.0. So if you see that, I got the amazing message on the console right now on the router number two saying that, hey, I'm able to form the neighborship with the 12.1. Same thing if you go with the R3 now. On R3, what we can do that? I'll go on R3 as the router EIGRP. EIGRP number one. EIGRP router ID will be 3.3.3.3. And my network will be 23.0. I got the neighborship up and my subnet of LAN network. So in a dynamic routing protocol, like I'm talking about the IGP perspective, EIGRP, OSPF, ISS protocol, REC protocol even, you advertise your directly connected route, right? So my directly connected route is the 23.0 on R3 and the 2.0 subnet. So 23.0 and the 2.0 subnet. And that's all. So now you can verify. So IP EIGRP neighborship. I can see that router 3 has a neighborship with the router number 2 right now. Same thing if you go on a router number 2 and quickly when I verify it. So IP EIGRP neighborship. I can see that router 2 is forming the two neighborship with the R1 and R3. Now, what we can do that? It's a quick video for the EIGRP, so let's verify it. So first of all, from the PC number 1, my main job is what? I want to check that do we have a LAN connectivity or not. So let's make a ping to the 1.2. It's working good right now. I'm getting the reply. Let's ping to the default gateway. Right. So whenever you're sending the traffic to the internet, right, or any different broadcast domain, first ping the default gateway. It's a best practice, right? It gives you the, uh, it identify you do we have a problem or not, right? So let's say example, if you're not able to ping your default gateway, it means that you have an issue in your LAN network itself right now. So my reply is getting good right now. It means that everything is good in my LAN side over here, right? Now I'm gonna ping from Delhi to the Bangalore. So I'm pinging from the 101 to the 2.3. Bingo. So it's all working good right now. We are getting the reply. Let's ping from the 2.1.1 to the 2.4 as well, which is this guy. And here we go. Okay. Now, the final thing, what we can do that, my ping is working good right now. I'll go on the router number 1. I'll show you the routes in the routing table as well. So IP route, you can see that I have a route in my routing table. So R1 knows the 2.0.0/24 subnet, right? And let's say example, In production network, what happened, you have a bunch of routes in your routing table. Personally, I have seen the lakhs of route, like 2 lakhs 3 lakhs of the route you will encounter in the production network. Even I have seen the 20 lakhs of route as well. So in that case, if you're going to put the command show IP route, it will show you all the routes in your routing table. So what you can do, that you can filter the routes as per the routing protocol behavior. Let's say example right now, if you see, when I put the command show IP route, it gives the information about the connected route and the EIGRP route as well. But I want to filter it. I want to see that only the EIGRP route. Then you can use the command show IP route EIGRP, and you can see that my routing table has been sorted. So we only have a 2.0 and 23.0 in my routing table. So if you have a bunch of route in your routing table and if you want to filter it, you can use the command show IP route EIGRP. Thank you so much, guys. I'll see you in the next video. Bye bye.